Hi, good evening to everybody. I'm very thankful to the panelists before with sort of laying down the basics so it helps me go to the point faster. Um, you see, architecture has always been sensitive to nature and climate and been sustainable always. It is only in the last few decades of engineering excellence that the engineering of buildings have taken over and they have put numbers to what was more ethereal and quantified things that are more ephemeral. So I would start with setting back the clock a bit. So if you look at an architecture and you start doing this from the way of how God the architect plays around with elements, chisel, and creates its own on uh, signages and iconic monuments. See, when water freezes and wind blows it up, you have stalactites like this. Design of any living being is so unique that however difficult or however complex the surrounding is, there's an animal which is adapted to that. Its camouflage, its antlers, its overall being designed for the place, designed for the habitat, designed for where it belongs. You can take any, I mean, this is a classic example I like to show. You take a zebra and you see the lines, they look similar, but they're not the same. You take thousands and thousands of them, and you find that they all might have similar stripes, but they all of them are different. Now, just look at the math in this number of millions of things that are similar in a time, and they have extremely separate fingerprints. It's like your own fingerprint, an identity. From a smallest animal, a snail, to as big as human beings, the curves, the shapes, they're so beautifully ephemerally designed. And you would like to think that when design happens, does it happen when you say, okay, let me be sustainable or let me uh, satisfy a particular context? Design is a continuous process of human intelligence to solve problems beautifully. So when we look at buildings, we create forms and try to impose forms on a site to be iconic and to have a signature building and so on. But like us, climate is the art of designing with climate. What we do is we take the hammer and chisel of sunlight, wind directions, the movement of sun across the seasons, the summer sun, its movement on a stereographic projection or a solar chart, as you call it, and how you design openings, windows, spaces, bring the exterior indoor, connect the inside to the exterior, have the buffer zones, spaces, your fenestration designs, your building envelope, the thermal mass of the envelope, what you want when you can't avoid sunlight or heat to come in, how you increase the phase lag, how you ensure you trap the heat inside, hold it for the night, all these things across. I mean, these are standard subjects in architecture, but when engineering comes in, it just somehow gets relegated to the back. So if you look at the whole of engineering industry, it's concrete, steel, wood, aluminum, glass, insulation, mechanical parts, whether it's HVAC or escalators or lifts and interiors. That's all. I mean, this is all that a building is about. There's no rocket science here. But if you look at the new age materials like graphene coming in, or you have fly ash, fly ash is very often quoted and used, but badly used, I would say. Then you have Vedic plaster, which does not need water to cure in hot places like Rajasthan. There are so many options of Adobe with straw and mud, eco smart boards. And so, what I'm trying to say is, over a period of time, we have evolved in our design thinking that let's take only schools, for example, and take 14, 15 different sites. You would see that the school designed by one architect from one office with the same staff have completely different way of looking at the context of the site, its contours, the directionality of the sun, where these children exit from the bus, where they sit together, how they catch, all these things which are so subtle and so centric to our design process, and that forms the fundamental backbone of sustainability. Now, we have all gone to the second and third flights. We have forgotten the first flight. The first flight is connect to the site, use what is minimum required, plan correctly, design intently, have the specifications that will sustain the building over not just from its embodied carbon or its life cycle carbon, but from carbon from this cradle to its grave, how you would put it to use, reduce the use of materials as far as possible for maximum square foot coverage and volumetric encompassing, use less material to build, sequester the carbon, make sure that what can go back to earth can go back to earth. What we take, but we also take not from our ancestors, we take it from future generations. It's also our responsibility to give back. With that, we had created Carbon Leadership Forum, and a lot of work went on to make sure that we start putting numbers because everybody wants numbers to quantify what is mostly non quantifiable. So we want you to take back. Let's once again learn from nature and build beautifully. There are a lot of work on biomimicry, on how honeybees build their honeycomb structures, how they keep the heat inside, how they ensure that in bright summer sun, the honey is not melting and it's not coming down by its own internal technology. Deep, sharp winter night when the temperatures go to 4 degrees, the honeybees don't get trapped inside and become solidified. So these are contexts which we can see in nature. But what do we do as architects? Do we really employ these thoughts? Do we put them to work in our buildings? Do we always say that for thermal comfort we need air conditioners, for lighting we need a bulb? Can we not light? It's a tropical country. Come on. There's so much of sunlight, light all around. Yet you see any office in Bangalore, in Delhi, in Goa, in whichever be the climate, good climate, harsh climate, you see curtains drawn, you see artificial lighting as a supplementary index. Even termites have learned the art of how to maintain temperatures by natural means. We knew this very well. See, India was once a forefront of engineering thinking. Till the time in the last few years, we have thought ourselves subservient and started copying the West. Look at this. In the last 10,000 years, nothing has changed. When I'm saying nothing has changed, the way sunlight travels across various materials, the way wind blows, the way the earth turns, what has changed? It's our understanding and our ability to harness the powers of nature to build that has come down. Though we have better tools, better technologies, movement from caves as the normal dwelling units to the penthouses, we have learned to grow in technology. But fundamental things like the power of the earth to naturally cool the air. In the summer, you get 18 degrees. In winters, you get 26 degrees. Natural sources lying right under our foot. But how many of us see that? Or how many of us use that? Look at all the architecture. What I was saying, the way sunlight comes through an opening in a straight line has not changed. It will not change. The way wind blows has not changed. How we can harness these into the buildings that we do is entirely what this whole debate or talk is about. And I'm very happy for Vaishali to have said we have to go beyond certification. And why I'm saying beyond certification, this is the Power Grid headquarters, SRTS2 RHQ building in Bangalore. It won the National Green Building Award. We got the first time some money from the government, 2 lakhs or something. And when we got this award, we felt very proud. But it was a struggle to get to prove by numbers to satisfy the Griha Council that we are this. And finally, when the certificate, we are 63 kilowatt hour per square meter per year. This is the EPI. A 63 EPI is an excellent building by world standards. People say anything less than 200 is a good building. Next year, we went on to do the Hindustan Petroleum, absolutely hot, harsh climate of Lucknow, and we got it to 70. But this was a very small footprint building. Then we went on 2 years back to do the income tax headquarters at 34.37 kilowatt hour. And when we did this, we're very proud to say this is going to stand as a monument in energy efficiency for many years to come before somebody can really beat this down. And one of the reasons why we're very proud of this is that a lot of effort went in right from every single material. And like Vaishali said, she showed a lot of buildings which are certified green buildings with the ugly glass boxes or dabba. I mean, I call it the typical Dubai architecture or Chinese architecture, just made dabbas. When you compare that with what we have tried to do. This is Kerala architecture by not just putting tiles on the sajja to call it Kerala architecture, but actually embodying the spirit of the Tacha Shastra of Kerala. And we've done 16-meter high columns, and we've done DGUs, recess windows, a lot of stuff that has gone in to get this number. But what is the Griha rating we have? It's a 3-star building. By any standard, it beats the best 5-star building. But because of the mundane certification processes, we have made sustainability and the art of designing better buildings a cumbersome process, a difficult task, a number game. And a lot of people have started greenwashing, putting up the necessary paperwork, and a lot of consultants. This was basically a failure of a Delhi based consultant who didn't put the papers rightly, I'm told, to, because I've missed some points. So, my friends, yad bhavo tad bhavati. You become what you believe in. If you believe that constraints of space are not limited to your surface, you can build a garden or a forest vertically. If you think that every drop of water counts, you can design your streetscapes in such a fashion that even your driveways are porous and you collect and consume every drop of water. Your architecture could define, you could use wood that looks like uh, straight rigid material that can be flowery. You can see columns coming from the top, which in this side, but you will see that the bottom columns are missing. The structure, the materials, the use of that to seamlessly integrate it with the rest of the buildings outside your perimeter, how it interacts with the shadow of the neighboring buildings, how you build well, how you use minimum lighting to create better light, how you use less luminaires to produce a better lux level. All those things from the crux of thing, because every line in architecture matters. It doesn't matter what place, what climate, what client you have. As an architect, as a consultant, it's your primary responsibility to build with less, to build better, to build more space, less material, to harness the powers of nature, to integrate natural light, because the time has finally come for the consultant engineer to think beyond self and to build the future, not merely just edifices that are gargantuan or iconic, but that are sustainable, non carbon intensive habitats. Today we build without sand, we build without clay, we build with fly ash, we build without wood, yet we look like wood, give the same feeling of wood, because we herald the future. We are responsible for a beautiful planet for our children. We must connect and then build. And with that, I will leave to say that you count your carbon in everything you do, because what you can't measure, you can't handle. For that, I'm thankful to the uh, certification agencies, because they made architects start counting the intangibles and put a number to that. Carbon neutrality is a target. The steps that lead to it is long and winding, I understand. But if we begin today, we would be able to build a carbon neutral, extremely sensitive, high energy efficiency buildings that respond to nature and that are a boon to cities rather than a bane, and we don't create more problems of what we have already done. Thank you.